Good afternoon, students. We have seen computer numerical control lathe. In the same way, operations are performed in vertical milling center. Okay, so this is called vertical milling center. That means a typical milling machine which is operating vertically is being automated. That's all. So you have seen milling machine. Okay, the same way it works. So we have something called as tool magazine here. Okay, there the comparison is tool post. Here we have something called as tool magazine. So in that we have lot of tools to be accommodated, and the machining center will take the tool according to the program. Okay, so the tool here is end mill. Okay, it's a multi-point cutting tool. So there we use single point cutting tool. Here we use multi-point cutting. Okay, so once the specimen is arrested in the vise, so there is a work holding device available here. You can see there, it is a work holding device which holds the workpiece, and the swing over diameter is 100 mm, swing over carriage is 80 mm. The speed of the spindle again here is 350 to 3000. Such a high RPM we are using. So we have a chain drive on the back side to help the milling center to accommodate the thrust force from the cutting. So whenever there is a cutting happens, again there is a thrust happens on the opposite side. So it has to be balanced so that there is a weight and pulley with a chain drive on the back side of the machine, and the same is being loaded in the front side. Okay, so here everything is motorized as same as CNC lathe. The movements are controlled by servo motors, and depth of cut is given by servo motors. Okay, so what is the speciality of vertical milling center and CNC lathe? In vertical milling center we have a palette of components. There only one component can be done at one time, but here we can do more number of components. We have a special palette, and then we can program the palette from, for example, we have first component here. According to that, we can take offset, initial position of the tool, then we start running the program. Every component, the tool goes and then do drilling. For example, you want to do drilling for 50 components. Okay, you can load at a time 50 components and then drill it in the same time. Okay, so this is how this vertical milling center works. Okay, so the same program is written with G codes and M codes in the machine, and again the same is being simulated. So there is a process of having simulation as well as running. Before going for running the program, there is a simulation that happens. Simulation is visual things of seeing the actual machining before machining. Suppose if there is any problem in the program, that can be sorted out from the program itself. Okay, so all these simulations will tell you or will reduce the cost of producing new components. So whenever you design a new component, so you write a program according to the drawing. Okay, so in that drawing you are writing CNC codes. Now the software itself, when you draw with the SolidWorks, it will generate the same codes. It will automatically generate the codes. So in that, if there is any problem, you can automatically see the simulation. You cannot go and take a component and then machine it. Then you can check with the component whether it is not okay. Then that component is wasted. Okay, raw material wastage is removed because of simulation. Right. So this is how this VMC works. Okay, so we have a very large axis. Number of axis is more. This is 3-axis VMC. We have 5-axis, 7-axis. Okay, so more complicated jobs like a sphere, everything, all the forms, starting from rectangle, sphere, cone, any geometry can be machined using this VMC, right? So this is all about VMC. Thank you.